There are places on Earth where fire sleeps beneath paradise, the Canary Islands. 7 emerald jewels scattered across the Atlantic, forged in violence, cradled by the sea. To the tourists who flock here each year, they are postcards of perfection, black sand beaches, volcanic wine terraces, eternal spring. But beneath the sunbathers and the sangria, something ancient stirs. La Palma. The locals call it La Bonita, the beautiful island. And it is. But beauty here is borrowed time. Because La Palma sits atop one of the most active volcanic systems in the Atlantic, a geological powder keg, a sleeping dragon that has awakened, again and again, throughout human history. September 19th, 2021. The dragon opens its eyes. At 3:12 p.m. local time, the ground beneath the village of Valparaiso begins to shake. Not violently, not yet. Just enough to rattle windows. To stop conversations mid-sentence. To make dogs bark at something invisible. Earthquake swarms. Dozens of them, hundreds. The Earth's restless heartbeat growing faster, louder, more insistent. Scientists at Spain's Volcanological Institute watch their screens with growing dread. They know this signature. They've seen it before, in textbooks, in case studies, in nightmares. Magma is rising. Cumbre Vieja, the old summit, a volcanic ridge running like a spine down La Palma's southern half. For decades it has been dormant, silent, forgotten by most. But not by geologists. Never by geologists. Because Cumbre Vieja has a history. A violent one. In 1949 it split open and bled lava for weeks. In 1971, it erupted again 3 vents simultaneously, fountains of fire painting the Atlantic night orange. Each time the island held its breath. Each time it survived. But 2021 would be different. Because this time, 7,000 people lived directly in the dragon's shadow. For 8 days, the earthquakes continue. Growing shallower, stronger, closer to the surface. Magma, relentless and patient, carving pathways through ancient rock. The island trembles like a living thing. Scientists issue warnings. Emergency plans activate. Evacuation routes are mapped. Families pack their lives into cars. Parents hold children close, whispering reassurances they don't quite believe. Shop owners lock doors for what they hope will be a few days. The elderly refuse to leave homes they've known for 70 years. The air itself feels wrong. Heavy, electric, as if the atmosphere knows what's coming. And then, on September 19th at 3:12 p.m., the earth tears itself open. A crack appears in the pine forest of Cabeza de Vaca. No warning, no countdown. Just sudden, violent birth. The ground splits like fabric, and from that wound the planet bleeds fire. A lava fountain erupts 200 meters into the air, 60 stories of molten rock launch skyward, with the force of jet engines. The roar is apocalyptic, primordial. The sound of creation itself. Within minutes, rivers of lava begin their inexorable march toward the sea. The Cumbre Vieja eruption of 2021 has begun. And for the next 85 days, nearly 3 months, La Palma will burn. This is not ancient history. This is not legend. This happened in our time, in our world, captured by satellites and smartphones, witnessed by thousands, streamed live across the planet. This is the story of an island that refused to die. Of scientists racing against geological time. Of families who lost everything but found strength in ash and darkness. This is the story of fire and water, of destruction and resilience. This is the story of Cumbre Vieja. The lava does not rush. It does not sprint. It crawls with the patience of geological time made visible. But make no mistake, it is unstoppable. From the moment the first fissure tears open on that September afternoon, molten rock begins pouring from the earth at temperatures exceeding 1,000 degrees Celsius. Hot enough to vaporize water on contact. Hot enough to turn steel into liquid. Hot enough to rewrite the landscape. The eruption site sits at 900 meters elevation, high on Cumbre Vieja's western flank. And, from there, gravity takes over. Multiple lava flows begin snaking downhill, following valleys, seeking the path of least resistance, toward homes. Toward villages, toward the Atlantic Ocean 6 kilometers away. Scientists watch with helpless fascination. They can predict the flow's general direction. They can model velocities, estimate volumes, project arrival times, but they cannot stop it. No one can. This is nature's mathematics. Inexorable. Indifferent. The first casualties are not human. They are homes. Within hours, the lava reaches the village of Valparaiso. Ironic, that name. Paradise. The black wall advances at walking speed slow enough to see, too fast to fight. Residents have already fled, but their possessions remain. A lifetime of memory is about to be erased. The lava meets the first house at sunset. There is no explosion. No dramatic collapse. Just the patient, terrible consumption of structure by stone. Walls glow orange, then white, then crumble into the molten mass. A child's bicycle melts into abstract sculpture. Family photos flash into ash. A garden lovingly tended for decades becomes volcanic desert in minutes. By nightfall, paradise is gone. But the lava is just beginning its feast. Over the following days and weeks, the flows multiply. The original fissure spawns new vents, new pathways for the Earth's fury. Lava flows merge, separate, merge again, a branching network of destruction advancing across La Palma's southwest. The numbers become abstractions. 100 buildings destroyed, then 500, then 1,000. Entire neighborhoods vanished, centuries-old churches consumed. Banana plantations, the island's economic lifeblood buried under meters of cooling basalt. More than 7,000 people evacuated. Refugees in their own homeland, and yet remarkably, miraculously, no one dies. This is the difference between disaster and catastrophe. Between tragedy and apocalypse. The early warning systems work. The seismic monitoring is precise. The evacuation orders are heeded. Spain's emergency services perform with quiet heroism, moving thousands to safety before the lava arrives. But survival is not the same as salvation. Maria Gonzalez stands at a police checkpoint, watching smoke rise from where her home used to be. She is 68 years old. She was born in that house. Raised her children there. Buried her husband from the garden he planted with his own hands. Now it is geology. Everything I am is under that rock, she tells a reporter, her voice steady, her eyes dry. Not from lack of feeling, from an excess of it. A grief too large for tears. She is one of thousands with identical stories. Meanwhile, the volcano's violence escalates. By late September, the eruption column reaches altitudes of 6,000 meters high, enough to disrupt air traffic across the Canaries. Ash falls like black snow on villages kilometers away. Roofs collapse under the weight. Cars are buried. The air becomes unbreathable without masks. Volcanic bombs, chunks of molten rock the size of refrigerators, are launched from the main vent, landing hundreds of meters away, starting fires wherever they strike. Sulfur dioxide gases billow from the crater, creating acid rain that withers vegetation and burns lungs. And still the lava flows. By October, multiple rivers of molten rock converge into a single, massive torrent nearly a kilometer wide. It advances on the coastal town of Tidok like a glowing glacier, devouring everything in its path. The town's church, Iglesia de San Pio X, stands directly in the flow's trajectory. Built in the 1970s, it has been the spiritual heart of this community for 50 years. Baptisms, weddings, funerals, generations of prayer soaked into its walls. Residents beg for a miracle, for the lava to split around it to spare this one sacred place. But the earth is not moved by prayer. On October 10th, the lava reaches the church. The building glows from within, stained glass windows shattering from heat before the walls themselves collapse. The bell tower, visible for miles, topples into the orange mass. Within an hour, there is nothing left but memory. And then, in early November, the lava finally reaches the ocean. This is the moment scientists have feared. When 1,000-degree lava meets cold Atlantic water, the reaction is explosive. Superheated steam erupts in towering clouds. Toxic gases, hydrochloric acid, sulfuric acid poison the coastal air. The sea boils. Fish float dead by the thousands. The lava builds a new delta, adding 48 hectares of land to La Palma's western coast. The island grows, even as it burns. But the most terrifying question remains unspoken. Hanging over every scientific briefing, every news report, every sleepless night, what if the flank collapses? There is a theory. A nightmare dressed in mathematics. And it haunts every volcanologist who studies the Canary Islands. The year is 2001, 2 decades before Cumbre Vieja's latest awakening. British geophysicist Dr. Simon Day and American volcanologist Dr. Stephen Ward publish a paper that sends shockwaves through the scientific community. Their hypothesis is elegant, terrifying, and disturbingly plausible. They propose that the western flank of Cumbre Vieja, a massive section of the volcanic ridge weighing billions of tons, is structurally unstable. That during a future eruption, this entire mountainside could collapse catastrophically into the Atlantic Ocean, and when it does, it would trigger a mega-tsunami, a wave that could cross the entire Atlantic basin. That could strike the eastern seaboard of the United States with walls of water 25 meters high. That could devastate coastal cities from Miami to Boston, from Lisbon to West Africa, a wave that could kill millions. This is the Phantom Tsunami, the disaster that hasn't happened. The apocalypse waiting in geological probability. The evidence, Day and Ward argue, is carved into the mountain itself. During the 1949 eruption, the last major event before 2021, something unprecedented occurred. As lava poured from multiple vents along Cumbre Vieja's spine, instruments detected something troubling. The western flank was moving. Not slightly, not subtly. 4 meters downslope. A vertical drop of 1 meter. An entire section of mountain, shifted by volcanic forces, held in place by friction and luck. Geologists documented a massive fracture running for kilometers along the ridge crest. A scar in the earth. A warning written in stone that no one fully understood at the time. Day and Ward looked at that fracture and saw a fault line. A geological time bomb. They calculated volumes, ran computer simulations, modeled wave propagation across ocean basins. Their conclusion: if Cumbre Vieja erupts violently enough, if seismic shaking is intense enough, if conditions align in just the wrong way, the flank could fail. Between 150 and 500 cubic kilometers of rock could slide into the Atlantic in a matter of minutes. For context, that's a mass equivalent to the entire island of Manhattan, multiplied hundreds of times over, entering the ocean at velocities approaching 100 meters per second. The displacement would be apocalyptic. Their paper, published in Geophysical Research Letters, ignites fierce debate. Some scientists embrace the hypothesis. The geology is sound. The fracture is real. The historical movement is documented. The physics of mega-tsunamis is well established. They've happened before in prehistoric collapses in Hawaii, in the Mediterranean, in Norway. But others push back hard. The probabilities are vanishingly small, they argue. The flank is more stable than Day and Ward suggest. The 1949 movement was localized, not indicative of total collapse potential. Computer models are only as good as their assumptions, and these assumptions are worst-case scenarios, not likely outcomes. The debate rages for years. Conferences, papers, counterpapers, computer models refined, challenged, refined again. And then September 19, 2021 arrives. When Cumbre Vieja erupts, the phantom becomes uncomfortably real. As lava pours and earthquakes shake the island, scientists worldwide hold their breath. Every seismic shock is analyzed. Every ground deformation measurement is scrutinized. Satellite radar tracks millimeter-scale movements of the mountain's surface. The question everyone is afraid to ask out loud: is this the eruption that triggers the collapse? Monitoring stations detect troubling signals. The western flank is deforming. GPS instruments show outward movement, the mountain bulging as magma intrudes beneath. Seismometers record thousands of earthquakes, some directly beneath the 1949 fracture zone. But deformation is not collapse. Movement is not catastrophic failure. The flank holds. Days pass, weeks. The eruption continues, violent and relentless, but the mountain remains intact. The nightmare scenario does not materialize. Scientists breathe cautious sighs of relief. The media, initially obsessed with mega-tsunami headlines, moves on to other disasters. But the question never goes away. Because here is the uncomfortable truth that volcanologists know but rarely say aloud. We cannot predict flank collapse with certainty. We can monitor. We can model. We can estimate probabilities. But the exact conditions that would trigger catastrophic failure, the precise threshold of seismic shaking, magma intrusion, water saturation, structural weakening, remain maddeningly elusive. It's like watching a cracked dam and trying to calculate exactly when it will burst. You know it's possible. You know the mechanisms, but you cannot know the moment. And so the Phantom Tsunami remains exactly that. A phantom. Not impossible. Not imminent. But not impossible. A low probability, high consequence event lurking in the statistical shadows of geological time. Dr. Day himself, in interviews after the 2021 eruption, is careful with his words. The collapse could happen in the next eruption, he says. Or in an eruption 1,000 years from now. Or never. But the thing about low probability events, he adds, is that they only have to happen once, and when they do, they rewrite history. The last confirmed mega-tsunami from a volcanic flank collapse occurred approximately 73,000 years ago in Cape Verde, also in the Atlantic. Geological evidence suggests waves over 200 meters high taller than a 60-story building scoured islands hundreds of kilometers away. There were no cities then. No millions living at sea level. No global civilization concentrated along coastlines. Now there are. And so, as Cumbre Vieja continues to burn through October and November of 2021, the world watches with double vision. One eye on the immediate disaster, the lava, the evacuations, the destroyed homes, the other on the phantom. The wave that hasn't come, the nightmare that remains theoretical. For now, the science beneath the fire. To understand Cumbre Vieja, you must first understand where Earth's fury comes from. Not from the heavens. Not from the gods. From deep within the planet itself. The Canary Islands should not exist. Look at a map. 7 volcanic islands rising from the Atlantic, hundreds of kilometers off the coast of Africa. But here's what makes them strange. They're nowhere near a tectonic plate boundary. Most of the world's volcanoes cluster along predictable zones. The Pacific Ring of Fire, where oceanic plates plunge beneath continents. Iceland, where the mid-Atlantic ridge tears itself apart. The Mediterranean, where Africa grinds slowly into Europe. These are the violent seams of our planet, where geology happens fast and loud. But the Canaries? They sit in the middle of the African plate. Stable crust. No subduction. No spreading ridge. No business by conventional logic hosting active volcanoes. And yet here they burn. The answer lies 150 kilometers beneath your feet. Deep in the Earth's mantle, far below the crust, exists a thermal anomaly. A hotspot. A column of superheated rock rising from near the core mantle boundary like a blowtorch pointed at the underside of the African plate. Scientists call it a mantle plume. Think of it as a geological highway for heat conduit channeling. Earth's internal furnace upward through thousands of kilometers of solid rock. When this rising plume reaches the base of the lithosphere, it doesn't punch through immediately. It spreads laterally, melting the overlying rock, creating vast chambers of magma. And eventually, when pressure overcomes resistance, that magma finds pathways to the surface. Volcanoes. This is how the Canaries were born. Not from plate collisions, but from the Earth's deep heat-finding expression. A hotspot, stationary in the mantle, while the African plate slowly drifts overhead. Like a geological assembly line. The islands formed sequentially, from east to west, over the past 20 million years. Lanzarote and Fuerteventura, first ancient, weathered, their volcanic fires largely extinguished. Then Gran Canaria. Then Tenerife, home to Spain's highest peak, Mount Tide. Then La Gomera, La Palma, and finally El Hierro, the youngest. Born less than 2 million years ago, still geologically restless. La Palma, approximately 1.7 million years old, sits in the sweet spot. Old enough to have built substantial height 2,400 meters above sea level. Young enough that magma chambers beneath remain active, connected to the mantle plume below. And Cumbre Vieja, the southern volcanic ridge, is La Palma's most recent expression of that deep fire. The magma itself tells a story. Laboratory analysis of Cumbre Vieja's lavas reveals their composition. Basalt, rich in iron and magnesium, relatively low in silica. This matters enormously. Silica content determines viscosity. High silica magmas, like those at Mount St. Helens or Vesuvius, are thick, sticky, prone to explosive eruptions. They trap gases, build pressure, detonate catastrophically, but basaltic magmas are fluid. They flow freely, gases escape more easily. Eruptions tend toward effusive rather than explosive lava fountains and flows, instead of pyroclastic surges and ash columns. This is why Cumbre Vieja, despite its fury, remains relatively predictable. The lava flows are dangerous, yes destructive, unstoppable. But they move slowly enough to evacuate ahead of them. They don't explode without warning. They don't generate the deadly pyroclastic density currents that erased Pompeii or Martinique. It's violence you can run from. But the magma's journey to the surface is anything but simple. Beneath Cumbre Vieja, seismic tomography, essentially a CT scan of the Earth's interior, reveals a complex plumbing system, multiple magma chambers at varying depths, networks of dikes and sills, sheet-like intrusions of molten rock squeezing through fractures in the surrounding stone. During the 2021 eruption, scientists track magma rising from depths of 30 kilometers. It stalls briefly at 10 kilometers, accumulating in a shallow reservoir. Pressure builds, rock fractures. The magma resumes its ascent. The earthquake swarms that precede the eruption, thousands of tremors over 8 days, are the sound of rock breaking, of pathways opening, of magma forcing passage through solid stone like water through cracking ice. By the time the first fissure opens on September 19th, the magma has traveled 30 kilometers vertically in less than 2 weeks. In geological terms, that's lightning fast. Once eruption begins, the system finds equilibrium. Magma rises at roughly the rate it is supplied from depth between 10 and 50 cubic meters per second during peak activity. Think of filling an Olympic swimming pool every minute. Sustained. Day after day. Week after week. This isn't a single explosive outburst. It's sustained supply. A tap left running from the Earth's mantle. The lava fountains reach heights of 200 to 600 meters, depending on gas content and eruption intensity. Volcanic bombs, semi-molten blobs of lava, are ejected ballistically, following parabolic trajectories before crashing back to Earth. The flows themselves move at speeds between 10 and 700 meters per hour, walking pace at the front. Faster in the channels where molten rock remains liquid. Temperature at emission, 1075 to 1100 degrees Celsius. Hot enough to make steel run like water. And volume? By the time the eruption ends 85 days later, Cumbre Vieja will have produced approximately 200 million cubic meters of lava. Enough to bury Manhattan under 30 meters of rock. But perhaps the most remarkable aspect of this eruption is not what happens, but what doesn't. The western flank does deform. GPS stations detect outward movement of up to 40 centimeters in some locations. The 1949 fracture zone shows renewed stress. But catastrophic collapse never occurs. Why? Scientists still debate. Perhaps the magma intrusion isn't large enough. Perhaps the flank's internal structure is more stable than models suggest. Perhaps groundwater saturation critical to lubricating potential failure planes is insufficient. Or perhaps it's simply not time yet, because geological time operates on scales that dwarf human civilization. What we call overdue might be, to the Earth, a blink. The volcano erupts. The island shakes. The flank holds. This time, the human-toll disasters are measured in numbers, but they are lived in moments. 3,000 buildings destroyed. 1,600 acres buried. 7,000 people evacuated. Euro 843 million in economic damage. These are the statistics that will be recorded in official reports, archived in databases, cited in academic papers. But they do not capture what it means to watch your world end in slow motion. Leticia Hernandez is 42 years old, a school teacher, mother of 3. Her family has lived on La Palma for 7 generations, farmers, fishermen, people who made their living from volcanic soil and Atlantic waters. On September 18th, the day before eruption, she receives the evacuation order. She has 2 hours. What do you take when you have 2 hours to pack a lifetime? Photo albums, important documents. Her grandmother's jewelry. Her children's drawings from kindergarten. A stuffed rabbit her youngest can't sleep without. What do you leave? Everything else. The furniture her grandfather built by hand. The garden her mother planted 30 years ago. The kitchen where she taught her daughters to make papas arrugadas. The bedroom where she nursed her babies at 3 a.m., watching dawn break over the Atlantic through curtains she sewed herself. All of it, left behind. She drives away with her husband and children, joining the convoy of cars streaming down mountain roads. In her rearview mirror, she can see smoke rising. She tells her children it will be okay, that they'll be home soon. She knows she's lying. The evacuees are housed in hotels, sports centers, the homes of relatives and strangers. The Spanish government acts swiftly: emergency housing, financial assistance, psychological support services, but there is no support for what comes next. The waiting, days turn into weeks, weeks into months. The eruption shows no signs of stopping. The lava flows continue their remorseless advance. And every evening, Letitia checks the updated maps online, tracing the orange boundaries that represent destruction. October 12th. Her neighborhood is consumed. She watches the footage on television, aerial drone shots. Her street glowing orange, dissolving into molten rock. Her home white walls, red tile roof, bougainvillea climbing the front wall, gone, erased, transformed into basalt. She does not cry. Not then. That will come later, in the middle of ordinary moments, reaching for a dish that isn't there. Looking for a photograph already burned, hearing her daughter ask when they're going home. That's when the grief ambushes her. She is not alone. Across La Palma, thousands share identical trauma. The paradox of survival, grateful to be alive, devastated by loss. Relief and rage existing simultaneously, tearing at the soul. Juan Garcia, 68, owned a banana plantation. 3 generations of work. The most productive land on the island, fed by volcanic soil, irrigated by ancient channels. He watched the lava consume it row by row over the course of 5 days. He had no insurance. Who insures against volcanoes on a volcanic island? His livelihood is gone. His retirement is gone. His legacy is gone. The volcano doesn't care about your plans, he says, his voice steady, his eyes somewhere else. It doesn't negotiate. And yet, amid the devastation, there are moments of defiant beauty. Neighbors share homes, food, resources without hesitation. Strangers become family. The island's solidarity is instantaneous, absolute. Donation centers overflow with clothing, supplies, money from across Spain and beyond. Volunteers arrive from the mainland, psychologists, structural engineers, disaster relief specialists. They work without pay, sleeping in tents, driven by nothing but the desire to help. The Spanish government pledges hundreds of millions in reconstruction funds. The European Union activates emergency assistance programs, but money cannot rebuild memory. Aid cannot restore what time created. For 85 days, the eruption continues. October bleeds into November. November into December. The lava shows no signs of exhaustion. Every few days, a new fissure opens. New flows begin. The destruction accumulates. Scientists cannot predict when it will end. Cumbre Vieja will stop when the magma supply is exhausted, when pressure in the deep chambers equilibrates. It could be tomorrow. It could be months from now. All anyone can do is wait. And then on December 13th, something changes. The lava fountains diminish. The seismic tremor, the constant vibration that has rattled the island for 3 months, begins to quiet. Gas emissions drop. Scientists watch their instruments with cautious hope. Is this a pause? Or is it ending? Days pass. The activity continues to decline. No new flows emerge. The existing lavas cool, their surfaces blackening, solidifying. On December 25th, Christmas Day, Spanish authorities make the official declaration. The eruption is over. The silence is surreal. For 3 months, La Palma has lived with constant noise. The roar of lava fountains, the rumble of collapsing structures, the hiss of superheated steam. And now, nothing. The island exhales. But the return is complicated. Some neighborhoods are completely buried, 20, 30, even 60 meters of lava covering what used to be homes, schools, churches. There is nothing to return to. The landscape has been rewritten. Other areas are intact but cut off, surrounded by fresh lava fields too hot to cross. Roads must be rebuilt. Infrastructure reconnected. Utilities restored. And everywhere the ash. Thick blankets of it covering surviving buildings, clogging gutters, infiltrating ventilation systems. Cleanup will take years. Leticia Hernandez stands at the edge of the new lava field in January 2022. Somewhere beneath this black desert is her home. She tries to orient herself. That hill used to be visible from her kitchen. That valley held the road where her children rode bicycles. But it's all gone. The topography itself has changed. She cannot even find where her house stood. She has a choice now: rebuild elsewhere. Leave the island. Start over. But this is home. This has always been home. The volcano took my house, she says. But it didn't take La Palma. And that, in the end, is the difference between disaster and defeat. The island survives. The people survive. And slowly, painfully, stubbornly, they begin again. The story of Cumbre Vieja is not over. The lava has cooled. The evacuees have returned or begun new lives elsewhere. But the volcano sleeps, not dies. And beneath La Palma, in chambers carved through ancient rock, magma still waits. The Earth's fury is patient, geological, inevitable. And there are hundreds of stories like this one, written in fire and ash across our planet. Volcanoes that have shaped civilizations, eruptions that changed history, mountains that sleep with one eye open. If you want to witness the raw power of our living planet, if you want to understand the forces that build and destroy in equal measure, then stay with us. Subscribe to Fury of the Earth, because the next eruption is already brewing. The next mountain is already trembling, and we'll be there to tell its story. But first, we must answer the question that has haunted scientists since 2001. The Phantom Tsunami. What would happen if the flank collapsed? How would the wave propagate? And who would be in its path? Let's find out. The wave that could be, imagine this. It is a future September morning. The sky over La Palma is clear, the Atlantic calm. Cumbre Vieja has been erupting for weeks, another cycle in the volcano's restless history. Lava flows, evacuations proceed smoothly. The island endures as it always has. And then, without warning, the mountain fails. A magnitude 6.5 earthquake strikes directly beneath the volcanic ridge. Not unusual during eruptions, but this one is different. This one hits the exact fault plane weakened by decades of magma intrusion, by the 1949 displacement, by countless seismic shocks. The western flank of Cumbre Vieja, a wedge of rock measuring 20 kilometers long, 15 kilometers wide, and up to 1.5 kilometers thick, begins to move. Not slowly. Not gradually. Catastrophically. In the first 30 seconds, the entire mass accelerates downslope, driven by gravity and lubricated by superheated groundwater flashing to steam. Friction cannot stop it. Nothing can stop it. The mountainside reaches velocities exceeding 100 meters per second faster than a Formula One race car before impacting the ocean floor 4,000 meters below. The energy released is equivalent to the explosion of several hundred nuclear weapons. But this is not an explosion. This is displacement. Between 150 and 500 cubic kilometers of rock, depending on which model you believe, enters the Atlantic Ocean in less than 10 minutes. The ocean has nowhere to go but up. And out. The initial wave is unimaginable. Computer simulations suggest a dome of water rising between 600 and 900 meters at the collapse site, taller than the world's highest skyscrapers, lifting skyward in seconds. This is not yet a tsunami in the traditional sense. It is a splash. A planetary-scale splash. But within minutes, that dome collapses outward, generating a series of waves radiating in all directions across the Atlantic basin. These waves are not like ordinary ocean swells. They carry incomprehensible energy. And they travel fast, approaching 800 kilometers per hour in deep water, the speed of a commercial jet. The tsunami races outward in expanding circles, like ripples from a stone thrown into a pond. Except this pond is an ocean. And this stone weighs billions of tons. The Canary Islands themselves are struck first. Within 20 minutes, neighboring islands Tenerife, Gran Canaria, El Hierro are hit by waves between 50 and 100 meters high. Entire coastlines are scoured clean, ports obliterated. Coastal cities erased. Tens of thousands dead before the world even understands what has happened. But the tsunami is just beginning its journey. 40 minutes after collapse, the wave reaches the African coast, Morocco, Western Sahara, Mauritania. Cities like Agadir and Casablanca, home to millions, face walls of water 10 to 25 meters high. There is no time for evacuation. No time for warning systems to propagate through bureaucracy. The waves arrive before comprehension does. Coastal infrastructure, ports, desalination plants, power stations is destroyed instantly. The economic devastation is incalculable, but the Atlantic crossing has only begun. 6 hours after the collapse, the tsunami reaches the Americas. The eastern seaboard of the United States braces for impact. NOAA's tsunami warning centers have been screaming alerts for hours, but preparation time is catastrophically insufficient. Miami. The wave arrives at low tide, a small mercy. But small is relative. Models suggest surge heights between 15 and 25 meters, depending on coastal geometry and bathymetry. South Beach vanishes beneath the surge. Downtown Miami floods to the 10th floor. Biscayne Bay becomes an inland sea. The causeways connecting Miami Beach to the mainland are swept away like toys. Evacuation routes are gridlocked. Millions trapped. Emergency services overwhelmed within minutes. Northward, the devastation continues. Charleston, Savannah, the Outer Banks, Norfolk. The wave refracts around capes, focuses in bays, amplifies in estuaries. Every indentation in the coastline becomes a funnel, concentrating energy. New York Harbor faces a surge between 10 and 20 meters. Lower Manhattan floods. The subway system already below sea level becomes a network of submerged tunnels. Wall Street, the financial district, Battery Park drowned. Boston, Portland, Halifax. Each coastal city struck in sequence, each facing waves calibrated to their unique geography. The Caribbean is not spared. The Lesser Antilles, Barbados, Martinique, Guadeloupe face waves from multiple directions as the tsunami wraps around island chains. Remote communities already vulnerable are simply erased. Even northern Brazil, despite being south of the direct wave path, experiences surges of 5 to 8 meters. The Amazon Delta is inundated with saltwater, poisoning freshwater systems for years. And then there's Europe. The tsunami propagates northeast as well as west. Portugal and Spain, facing the Atlantic, are hit within 2 to 3 hours. Lisbon, built on the site of the catastrophic 1755 earthquake and tsunami, faces history repeating with modern population density. The wave continues into the English Channel, the North Sea. Coastal cities from Bilbao to Bordeaux to London experience flooding. Even the Mediterranean feels echoes, as the tsunami refracts through the Strait of Gibraltar. The death toll in this scenario is almost impossible to calculate. Conservative estimates suggest hundreds of thousands dead in the immediate impact, drowned, crushed by debris, swept out to sea, but the secondary toll is far worse. Infrastructure collapse. Power grids down. Water treatment plants destroyed. Hospitals flooded. Supply chains severed. Millions displaced. Refugee crises on unprecedented scales. Coastal megacities, the engines of the global economy, offline for years. The economic impact runs into trillions of dollars. Not millions. Not billions, trillions. Insurance markets collapse. Governments struggle to respond. International aid systems are overwhelmed. And this assumes the collapse happens with warning, during an active eruption, when some level of preparedness exists. If it happens without an eruption, without precursor earthquakes, with no warning at all, the toll could be 10 times worse. But here is what you must understand. This is a scenario. A simulation. A nightmare built from physics and probability. It has not happened. It may never happen. The probability of catastrophic flank collapse during any single eruption is estimated between 0.01% and 1%. Depending on which volcanologist you ask, low, very low. But not zero. And in a world of 8 billion people, with hundreds of millions living at sea level, with global civilization dependent on coastal infrastructure, low probability, high consequence events demand attention. Because geological time is patient. But it is not infinite. Cumbre Vieja will erupt again. Maybe in 50 years, maybe in 500. And each time it does, the question returns. Is this the one? Some scientists argue the risk is overblown. That the flank is more stable than early models suggested. That the 2021 eruption, violent, sustained, and yet without collapse, proves the danger is exaggerated. Others disagree. They point to the continued deformation, the persistent fracture zone, the documented instability. The debate continues. The monitoring continues. The volcano sleeps, but the phantom tsunami remains. A possibility. A probability distribution. A future written in mathematics in stone, and somewhere in the Atlantic the wave waits. Not real, not yet, but not impossible. Guardians of the volcano in the shadow of Cumbre Vieja, there are people who do not sleep. Not figuratively. Literally. While the world watches volcanic eruptions as spectacles, dramatic footage, breaking news, social media posts, there exists a small community of scientists for whom every tremor, every gas emission, every millimeter of ground deformation is a data point in an endless vigil. They are volcanologists, geophysicists, seismologists, the guardians of the volcano. Dr. Nemesio Perez is the scientific director of INVOLCAN, the Canary Islands Volcanology Institute. He has spent 3 decades studying these islands, these mountains, these restless giants. When Cumbre Vieja begins its earthquake swarms in September 2021, he does not go home. For 85 days, he and his team work in shifts around the clock, monitoring seismographs, analyzing gas samples. processing GPS data, updating hazard maps. Sleep becomes a luxury measured in hours, not nights. People ask me if I'm afraid. He says in an interview during the eruption, his eyes red-rimmed with exhaustion. I'm not afraid of the volcano. I'm afraid of not understanding it in time. That is the burden of volcanic monitoring. The responsibility of prediction without certainty, of warning without guarantees. The tools at their disposal are sophisticated, but they are not magic. Seismometers scattered across La Palma detect earthquakes too small for humans to feel micro-tremors that reveal magma moving beneath the surface. Each earthquake is located in three-dimensional space, its depth and magnitude calculated within seconds. GPS stations measure ground deformation with millimeter precision. When magma intrudes beneath a volcano, the mountain swells, slowly, subtly, but measurably. Gas sensors sample the composition of volcanic emissions. Rising magma releases dissolved gases, sulfur dioxide, carbon dioxide, hydrogen sulfide. Changes in gas ratios can indicate magma depth, ascent rate, eruption probability. Thermal cameras track surface temperature. Satellite radar monitors deformation from space. Drones equipped with multispectral sensors map lava flows in real time. It is an orchestra of technology all playing the same piece, the volcano's heartbeat. But data is not prophecy. Volcanoes are complex systems, nonlinear, chaotic, stubbornly resistant to simple prediction. Two eruptions can have identical precursors and vastly different outcomes. Or no precursors and sudden violence. The 2021 eruption gives approximately 8 days of warning, enough time to evacuate. But it is not always so generous. In 2018, Kilauea in Hawaii transitions from slow lava lake activity to catastrophic flank eruption in less than 24 hours. In 2014, Mount Ontake in Japan erupts without meaningful seismic warning, killing 63 hikers. Volcanoes do not follow rulebooks. And yet the monitoring continues because it works. The difference between disaster and catastrophe is often measured in hours. Hours to evacuate. Hours to prepare. Hours that monitoring systems provide. During the 2021 eruption, not a single person dies from the lava flows. Not one. Despite 7,000 people living in the impact zone. Despite 3,000 buildings destroyed. This is not luck. This is science. This is vigilance. The seismic swarms are detected, the hazard zones are mapped. The evacuation orders are issued with enough lead time for people to leave safely. Property can be rebuilt. Lives cannot. But the phantom threat, the flank collapse, the mega-tsunami presents a different challenge entirely. How do you monitor for an event that has never happened in recorded history? How do you establish warning thresholds for something unprecedented? After the 2021 eruption, monitoring networks on La Palma are expanded significantly. More seismometers, more GPS stations, more sophisticated ground-penetrating radar to image the internal structure of the volcanic edifice. Scientists from around the world collaborate on modeling efforts. Supercomputers run simulations. Researchers drill cores to understand the mechanical properties of the rock. Submarine surveys map the seafloor, searching for evidence of past collapses. The goal is to establish a baseline. To understand what normal instability looks like, so that abnormal instability can be recognized before it becomes catastrophic, but it is fiendishly difficult. Rock masses do not fail predictably. They accumulate stress over decades, centuries, millennia, then fail suddenly, without linear warning signs. It's like predicting exactly when a rope will snap under increasing load. You know it will happen eventually. You know the mechanisms. But the exact moment remains elusive. Dr. Day, the geophysicist who co-authored the original 2001 tsunami paper, remains cautiously optimistic about monitoring capabilities. If a catastrophic collapse were to begin, he explains, there would almost certainly be precursor signals. Accelerating deformation, increasing seismicity, changes in gas emissions. The question is whether we would recognize those signals in time, and whether we could evacuate effectively. The Atlantic Basin has tsunami warning systems, but they were designed for seismic tsunamis, those generated by underwater earthquakes, detection buoys, seismometers on the ocean floor, travel time models. A flank collapse tsunami would be different. Faster initial wave generation, different frequency characteristics, and most critically potentially less warning time. From initial collapse to wave arrival in Morocco. 40 minutes. 40 minutes to detect, analyze, confirm, disseminate warnings, and begin evacuations. It is not enough. Not nearly enough. And so the Guardians watch. And wait, every earthquake is logged. Every deformation episode is analyzed. Every eruption is studied for clues about the system's deeper behavior. Because the alternative, ignoring the risk, hoping it never happens, is unacceptable. Low probability does not mean impossible. It means rare, and rare events still occur. The 2004 Indian Ocean tsunami was rare. The 2011 Tohoku earthquake was rare. The eruption of Mount Pinatubo in 1991 after 500 years of dormancy was rare, and yet they happened. And they killed hundreds of thousands. Volcanic monitoring is an act of eternal vigilance against the improbable. It is scientists spending careers studying mountains that may never erupt in their lifetimes. It is funding agencies maintaining networks that may never detect the catastrophe they were built to prevent. It is unglamorous work. Routine data collection, software maintenance, sensor calibration, grant applications, budget justifications. Until suddenly, it's not routine anymore, until the mountain wakes. And the data matters. And lives depend on it. Dr. Perez, exhausted, covered in volcanic ash, stands at an observation point overlooking the erupting Cumbre Vieja in October 2021. Behind him, lava fountains rage against the night sky. Before him, hazard maps glow on laptop screens, updated in real time as new flows emerge. A reporter asks him why he does this work. Why dedicate his life to watching mountains that might kill him? He pauses, thinks, then answers simply. Because someone has to. Because if we don't watch, no one will know when to run. And in the end, that is the covenant between science and society. The volcano will do what the volcano will do. But we do not have to face it blind. Echoes of the past. Cumbre Vieja is not the first mountain to threaten collapse into the sea. It is not even the first in the Canary Islands. To understand the phantom threat, we must look backward, to eruptions that came before, to collapses that actually happened, to the geological record written in stone and legend. Because the Earth has done this before. Approximately 560,000 years ago, the northern flank of El Hierro, the youngest and westernmost of the Canary Islands, fails catastrophically. Not during an eruption. Not with warning. Simply ... fails. A wedge of rock measuring over 150 cubic kilometers slides into the Atlantic, generating a tsunami that likely exceeded 100 meters in height. The evidence is carved into the seafloor, a massive debris field extending 50 kilometers from the island, visible on bathymetric surveys even today. On El Hierro itself, the scar remains. A horseshoe-shaped bay called El Golfo, its cliff walls rising 1,000 meters directly from the sea. This is not erosion. This is amputation. An entire section of island gone in minutes. And it happened again. Multiple times. Tenerife shows evidence of at least 3 major flank collapses over the past million years. Gran Canaria, 2. La Palma itself has a massive collapse scar on its northern end. The Caldera de Tabarinte, formed approximately 560,000 years ago when the Tabarinte volcano's flank slid into the Atlantic. The Canary Islands are built on a foundation of catastrophic failures. But this is not unique to the Canaries. Volcanic flank collapses are a global phenomenon, written into the geology of nearly every oceanic volcanic system. Hawaii, the Big Island. Mapping of the seafloor surrounding the Hawaiian archipelago reveals one of the most astonishing geological discoveries of the 20th century. Debris avalanches. Dozens of them. Massive landslides extending hundreds of kilometers across the ocean floor, some containing more than 5,000 cubic kilometers of rock. The Alika debris avalanche, approximately 105,000 years ago, sent an estimated 1,500 cubic kilometers of Mauna Loa's western flank into the Pacific. Computer models suggest the resulting tsunami exceeded 400 meters taller than the Empire State Building when it struck the neighboring island of Lanai. The evidence is still there. Coral deposits found 300 meters above current sea level on Lanai, ripped from the ocean floor and deposited by the wave. 400 meters. Let that sink in. Even more recently, geologically speaking, Ritter Island in Papua New Guinea collapsed in 1888, not 560,000 years ago, not 105,000 years ago. 1888. The age of steam engines and telegraphs. On March 13th, the volcanic island's northern flank fails during a relatively minor eruption. Approximately 4 cubic kilometers of rock enters the Bismarck Sea. The tsunami that follows is devastating. Waves exceeding 12 meters strike coastlines across the region. Villages on neighboring islands are obliterated. An estimated 3,000 people die. But the Pacific is vast, the region sparsely populated. The event is documented but not widely known. A footnote in history. Had Ritter Island been in the Atlantic, facing New York instead of Papua New Guinea, history would remember it very differently. Perhaps the most famous collapse, though not volcanic, occurred 8,200 years ago off the coast of Norway. The Storegga Slide. A submarine landslide triggered by earthquakes and methane hydrate destabilization. An estimated 3,500 cubic kilometers of sediment, more than twice the volume of the largest Hawaiian, collapses slid down the continental slope into the Norwegian Sea. The resulting tsunami crossed the North Atlantic. Scotland was struck by waves 20 meters high. The coastline of Norway experienced surges exceeding 10 meters. Doggerland, a now submerged landmass connecting Britain to continental Europe, was inundated, possibly accelerating its final submergence beneath the North Sea. Stone Age settlements were destroyed. Entire populations displaced. Oral traditions across Scandinavia may preserve memories of this event, encoded in flood myths passed down through 8,000 years of human culture. The Earth remembers. Even when we forget. But these are prehistoric events. Deep time. Beyond the reach of written records. What about modern history? What about collapses witnessed by civilization? Mount St. Helens, 1980. On May 18th, a magnitude 5.1 earthquake triggers the collapse of the volcano's northern flank. 2.5 cubic kilometers of rock, the entire summit and upper north face slides downhill at speeds exceeding 200 kilometers per hour. It is the largest landslide in recorded history. The debris avalanche travels 22 kilometers, filling valleys to depths of 200 meters. Behind it, the now exposed magma chamber explodes laterally, releasing a pyroclastic density current that obliterates everything within a 30-kilometer arc. 57 people die. Most not from the eruption itself, but from the collapse. And Mount St. Helens was monitored. Scientists knew it was active. They issued warnings. They established exclusion zones. But no one predicted the flank would fail so catastrophically, so suddenly. The mountain simply fell apart. These events share common threads. Steep volcanic edifices built rapidly over geological time. Rock fractured by intrusions, weakened by hydrothermal alteration, saturated with groundwater. And a trigger, sometimes an earthquake, sometimes an eruption, sometimes nothing discernible. The physics is straightforward. The timing is not. Flank collapses are threshold events. Stress accumulates slowly, invisibly, over centuries or millennia. Then, at some critical point, when one more cubic meter of magma intrudes, when one more earthquake shakes fractured rock, when pore pressure from groundwater exceeds a critical value, the system fails. Instantly. Irreversibly. Like the final grain of sand that triggers an avalanche. Impossible to predict with precision. Obvious only in retrospect. And so we return to Cumbre Vieja, steep, yes, rapidly built, yes, fractured. Documented. Hydrothermally altered? Confirmed? Saturated with groundwater? Almost certainly. Does this mean collapse is imminent? No. Does it mean collapse is possible? Unquestionably. The 1949 deformation proves the flank is mobile. The 2021 eruption proves the system remains active. The geological record of the Canary Islands proves that catastrophic collapses happen here. The question is not if. The question is when. And when, in geological terms, might be next week. Or in 10,000 years. Dr. Day, reflecting on 2 decades of debate since his original paper, puts it plainly. Every volcanic island and every ocean basin will eventually experience flank collapse. It's part of the life cycle. The islands grow, become unstable, and fail. And then they grow again. The Canary Islands are young, geologically speaking. They're still in their growth phase, which means the collapses are not finished. He pauses. The only question is whether civilization will be watching when the next one happens. Living with the dragon. There's a word in Spanish that has no perfect English translation. Convivor. To live with. to coexist. To share space with something that cannot be controlled, only accepted. This is the relationship between the people of the Canary Islands and their volcanoes. In December 2021, when the eruption finally ends, La Palma faces a choice: abandon the island, declare it too dangerous, resettle the population elsewhere, write off the losses, move on. Or stay, rebuild, accept the risk as the price of paradise. The choice is not even close. Within weeks, residents begin returning to whatever remains. Homes buried under lava are mourned and abandoned. Homes spared are cleaned, repaired, reoccupied. The island exhales and resumes breathing. Because this is home. This has always been home. For the people of La Palma, the volcano is not an invader. It is family. Dangerous, unpredictable, occasionally destructive, but family nonetheless. This relationship is ancient. The Guanches, the indigenous people of the Canary Islands before Spanish colonization, built their entire civilization in the shadow of active volcanoes. They farmed volcanic soil. They carved homes into volcanic rock. They worshipped at volcanic peaks, believing them to be dwelling places of gods. When eruptions occurred, they did not flee permanently. They relocated temporarily, waited for the mountain's anger to pass, then returned to rebuild. This pattern has repeated for millennia. The 1730 to 1736 eruption on Lanzarote, one of the longest eruptions in recorded history, buried a quarter of the island under lava. 6 years of continuous volcanic activity. Entire villages consumed. The most fertile farmland transformed into a desolate volcanic desert now called Timanfaya. And yet people stayed. They adapted. They learned to grow crops in volcanic ash, to harvest moisture from the porous rock, to turn disaster into survival. Today, Lanzarote's wine industry, internationally renowned, exists because farmers discovered that vines planted in volcanic gravel and protected by stone walls thrive in ways conventional agriculture cannot match. The volcano destroyed. The people transformed. This resilience is not romantic naivety. It is calculated coexistence. The people of the Canary Islands understand risk better than most. They grow up with earthquake drills. They live with evacuation plans posted in public buildings. They watch the monitoring networks, the seismograph feeds, the scientific bulletins. They know the mountains can wake at any time. But they also know that volcanic soil is the richest on Earth, that tourism thrives on volcanic landscapes, that geothermal energy, still largely untapped in the Canaries, could power the islands for generations. The volcano gives as much as it takes, and so they stay. But the Phantom Tsunami complicates this relationship. A local eruption is containable risk. Lava flows can be predicted, evacuations executed, losses minimized, you can see it coming. You can run, but a catastrophic flank collapse? A transatlantic mega-tsunami? That is different. That is existential. Not just for La Palma, but for millions who have never heard of Cumbre Vieja, who have never thought about volcanic collapses, who live their lives blissfully unaware that a mountain on an island they couldn't locate on a map could fundamentally alter their future. How do you convive with that? After the 2021 eruption, the Spanish government invests heavily in improved monitoring and early warning infrastructure. New seismometers, expanded GPS networks, enhanced tsunami detection buoys in the Atlantic, revised evacuation protocols, international cooperation agreements with nations across the Atlantic basin. The goal is not to prevent collapse, that is impossible, but to maximize warning time. If the flank begins to fail, if deformation accelerates beyond critical thresholds, if seismicity indicates imminent, catastrophic movement, then warnings must be disseminated within minutes. Not hours, minutes. Coastal communities from Morocco to Miami must receive alerts with enough time to move to higher ground. 40 minutes is not much, but it is infinitely better than zero. There are proposals, more radical ones. Some engineers have suggested physical intervention. Massive drainage systems to reduce groundwater pressure within the flank. Structural reinforcement with deep anchor bolts. Even controlled demolition, removing the unstable section in small, manageable collapses rather than one catastrophic failure. But these are engineering fantasies. The scale is too vast. The cost too high. The risk of triggering the very collapse you're trying to prevent too great. You cannot stabilize a mountain. And so the focus remains on monitoring, modeling, and warning. Dr. Perez, in the aftermath of the 2021 eruption, is asked what keeps him awake at night. He does not hesitate. The thought that we might miss something. That the signs will be there but we won't recognize them in time. That people will die because we didn't understand quickly enough. He pauses. But also the opposite fear. That we'll issue warnings that turn out to be false alarms. That will evacuate millions, disrupt economies, cause panic, and nothing happens. Because if we cry wolf too many times, people stop listening. And then, when the real threat comes ... he doesn't finish the sentence. He doesn't need to. This is the tightrope of disaster prediction. Too cautious and you're ignored. Too bold and you're culpable. And yet the work continues. Because the alternative, doing nothing, hoping for the best, trusting in luck, is morally unacceptable. Volcanoes will erupt. Flanks will collapse. Tsunamis will propagate. These are not possibilities. These are certainties written to the geological future as surely as the past. The only variables are when, where, and whether anyone will be ready. On La Palma today, life has returned to a new normal. The lava fields of 2021 are still black, still cooling, still too hot to touch in places, but around them resilience blooms. New roads snake around the fresh basalt. Houses are rebuilt farther from the volcanic ridge this time, but not far enough to leave the island. Schools reopen. Businesses restart. The airport resumes full operations. Tourists return, drawn by the raw spectacle of recent creation. Volcano tourism surges. The island's economy, battered but unbroken, begins recovery. And the scientists remain, watching, measuring, waiting, because the dragon sleeps, but it does not die. Beneath Cumbre Vieja, magma chambers refill. Tectonic stress accumulates. Fractures remain. The flank, slightly deformed by the 2021 eruption, settles into new equilibrium. For now, the next eruption might be decades away, or it might be next year. The catastrophic collapse might never happen, or it might happen tomorrow. This is the reality of living on a volcanic island in an active oceanic hotspot. Uncertainty as a way of life. Risk is the rent for paradise. And perhaps that is the most profound lesson of Cumbre Vieja. Not that disasters are coming, we've always known that. But that civilization endures not by eliminating risk, but by learning to coexist with it, by watching, by preparing. By accepting that we live on a planet that is not stable, not safe, not designed for our comfort. A planet that builds mountains and tears them down. That births islands and drowns them. That giveth and taketh away with equal indifference, and yet we stay. We build our homes on volcanic slopes, we farm volcanic soil. We draw our water from volcanic aquifers. We harness volcanic heat. We live with the dragon, not because we are foolish, but because we are human. And humanity has always chosen to live at the edge of danger, where the soil is richest, where the views are most spectacular, where life is most intense. The people of La Palma understand this better than most. They have lost homes. They have lost livelihoods. They have watched their island burn for 85 days straight, and they remain because the volcano does not own them. They own themselves. And they choose, freely and knowingly, to stay conviver, to live with the dragon, to coexist with fire, to call paradise home, even when paradise occasionally tries to kill you. This is not resignation, this is defiance. And in that defiance lies something profoundly, defiantly human. The refusal to be driven from home by fear. The insistence that we belong here on this restless planet in this dangerous universe, that we will watch, we will prepare, we will adapt, but we will not run. The sun sets over La Palma. The Atlantic glows gold, then orange, then deep purple. Cumbre Vieja stands silhouetted against the fading light scarred, still smoking faintly, beautiful and terrible. Somewhere in the valley below, lights flicker on in rebuilt homes. Life continues. The dragon sleeps. And the people remain.